All right, let's jump right into the left seat of the Bombardier Q400. Picture this, you're cruising along, the weather outside is getting pretty nasty, and bam, an amber DEICE press caution light glares right at you from the panel. Well, today, we're unpacking exactly how to handle that. In this explainer, we'll run through our left seat simulation to help you lock in this emergency checklist so it literally becomes muscle memory. So let's get into it.
Okay, real quick, here's our flight plan for today. We're going to run through the initial caution light actions, check out the DEICE pressure, cover what to do for normal pressure light failures, hit the abnormal pressure procedures, and finally, wrap up with our icing landing considerations.
Starting off with Section 1, the initial caution light actions. We're talking about those absolutely crucial first 10 seconds.
So, the moment that amber light pops on, these are your non-negotiable next steps. Timing is everything here. First thing you do? Switch that airframe mode selector right into manual. Then, you wait, exactly 10 seconds. After that pause, you select slow or fast, depending on what your conditions require. The easiest way to drill this into your head is the rule of 10 memory trick. Just think, manual means wait 10. You just link the M in manual to the 1 and 0 of 10. Manual means wait 10. And then, and only then, do you move to your slow or fast cycle.
Moving on to Section 2, let's look at checking your DEICE pressure and really evaluating that indicator.
Now you might be wondering, what if that initial procedure doesn't fix it? What if that DEICE press caution light just stubbornly persists? Well, this is a literal fork in the road for our Q400 checklist. If that amber light is still staring you down, you've got to immediately check two things: the boot air ISO and the DEICE pressure indicator. We've got to see exactly what that pressure is actually doing.
And what are we hoping to see on that indicator? Ideally, normal indication for both the number 1 and number 2 systems, which is 18 plus or minus 3 psi. And a super simple way to never forget this during an emergency, use the legal age trick. Just tell yourself DEICE pressure is like the voting age, 18, give or take 3. It's a silly little trick, but trust me, it's going to pop right into your head the second you scan that gauge.
All right, so if you do see that healthy 18 psi, your immediate next move is to check the DEICE panel. You've got to actively watch your boot advisory lights while the system runs its slow or fast cycle. You're looking to make absolutely sure every single light is doing its job and illuminating correctly.
Okay, Section 3. Let's talk about what happens when you have normal pressure, but the lights themselves fail.
So, let's say your pressure is good. You've got your 18 psi, but during the cycle, an advisory light completely fails. This is where things get interesting. For boot systems 1 or 2, if just one light fails, you exit icing conditions ASAP. Same general idea for systems 3 or 4. If both number 3s or both number 4s fail, get out of the ice immediately. But take a look at systems 5 and 6. If even one light fails here, you have to open the engine intake doors before exiting icing. This brings up our next memory trick. 5 and 6 need air. Think about it. Boots 1 through 4 are your wings. Just get out of the ice. But 5 and 6, those are your engines. And engines, well, they need to breathe. So remember, 5 and 6 need air. Yank those engine intake doors open to protect your power plants.
And here's a massive, absolutely crucial follow-up. Once you're successfully out of the icing, you have to do an aerodynamic check. If your aircraft is still lugging around ice and is not aerodynamically clean, throw your normal speeds right out the window. You've got to grab the manual and reference page 2.7 for your minimum airspeed in flight in icing conditions. Whatever you do, do not let that Q400 get too slow while you've got contaminated lifting surfaces.
Which brings us to Section 4, the abnormal pressure procedures. This is what we do when pressure drops or multiple lights fail.
So what if your pressure wasn't a healthy 18 psi? This is a major branching path in our simulation. Pay close attention to these triggers because they happen fast. You launch into this emergency sequence if the DEICE pressure indication is abnormal, or if 2 or more wing DEICE boot advisory lights on the exact same side fail. If either of those hit, you fire off a rapid 3-step action plan. Action 1, exit icing ASAP. Action 2, throw the engine intake doors open. Action 3, switch the airframe mode selector to manual. It's a fast, super decisive flow to get the aircraft secured.
Now, pause right here because you need to be incredibly careful with this next part. The source material hits us with a bolded safety caution. Caution: do not select the wing positions during manual de-icing of the tail and engine intake. Basically, if you are managing abnormal pressure manually, absolutely do not touch the wings while handling the tail and engines. If you do, you could completely compromise whatever precious little pressure you have left.
So how do we actually execute this manual control? Well, your action is to move the airframe manual selector to tail and engine, and you let it dwell there for about 6 seconds. But keep this incredibly stark operational note in the back of your mind. While you're doing this 6-second hold, only the engine intake boot on the side that actually has normal pressure is going to get de-iced. Your system is totally asymmetrical at this point. You do the hold, but mentally, you need to be perfectly aware that only the healthy side is shedding that ice.
All right, final stretch. Section 5, Icing Landing Considerations. It's time to adjust your approach.
Okay, we've handled the immediate cautions, checked our pressures, isolated the failures. Now we've got to get this bird on the ground. If you're landing in icing conditions, or if the aircraft is still holding onto ice, your standard landing profiles are totally out the window. First off, it's mandatory that you land at either flap 10 or flap 15. No exceptions. Also, if you find yourself holding in a clean configuration with 0 flaps, your minimum hold speed is a whopping 190 knots. You desperately need that high airspeed to maintain safe lift margins over the ice.
And this brings us to the math for a safe touchdown. Notice these speed additives. For flap 5 and flap 10, you're adding 30 knots to your approach speeds. That's your VAP, VGA, or VREF. But for flap 15, you only add 25 knots. My favorite way to memorize this, the add 30, drop 5 rule. You start by adding 30 knots, but when you step down to that final flap 15 setting, you just drop 5 knots off your additive, giving you plus 25. Now check out the landing distance factor for flap 10 and 15. It's a massive 1.80 multiplier. To lock that one in, just think 80% extra. A factor of 1.80 literally means you need 80% more runway than a normal clean landing. 80% extra gives you that 1.80 instantly.
So this brings us to our final left seat reality check. If that ice just refuses to clear, are you truly prepared to calculate that 1.80 landing distance factor before you touch down? Do you actually have 80% extra runway waiting for you at your destination? It's a lot to think about. But if you master the rule of 10, remember the voting age of 18 plus or minus 3, know that 5 and 6 need air, and always account for that 80% extra runway, you're going to nail your next simulation. Thanks for flying through this explainer with me.